Welcome back, all you calcsters, to another weekend review and preview. I'd like to start by reviewing derivatives by definition. The two limit definitions that we have are for at a point and of a function. So we can find the derivative of a function at a point using this limit definition right here. So what we're doing in this limit definition is inputting the x value that we are approaching. So c would go here, here, and here. And then we put the function where f of x is, and we do the function evaluated at a number, the value of c, in the other place. And I'll show a specific example of that in a moment. And we also learned about how to find the derivative of a function using this limit definition, where we replace x in the function with x plus h for the first part. Then we have the entire function just as normal divided by h. Knowing that in both of these types of problems, we end up having to simplify so that we are able to directly substitute in and evaluate. All right, so let's look at an example of calculating the derivative at a point for the function f of x is equal to x cubed minus 6 at a c value or an x value of 2. So using my limit definition, it would be the limit as x approaches 2 of the function minus the function evaluated at the given c value over x minus c, which in this case is 2. So from here, I'm going to do some algebraic simplification. In my brackets here, I'd have 8 minus 6, which would end up being 2. So then when I simplify, limit as x approaches 2, I'd have x cubed minus 6 minus 2 over x minus 2. And that would simplify to the limit as x approaches 2 of x cubed minus 8 over x minus 2. Now at this point, if I tried to substitute in directly, I would get 0 over 0, which means that I need to simplify. So I will do so with a little bit of polyduco here. So I'm going to do x and minus 2. I know my first term is x cubed, which means I would need an x squared up here, which means down here I would have negative 2x squared. Since I have no x squared, I need this to be a 2x squared to cancel that out, which means this will be a plus 2x. This down here would give me negative 4x, and since I have none of those terms, I would need this to be 4x right here. That would be plus 4, and that would give me the minus 8 that I need. So if you'll notice, these cancel, I'm left with x cubed minus 8, which is exactly what I have in my numerator. So what that means is x cubed minus 8 divided by x minus 2 is equal to x squared plus 2x plus 4. So I can now evaluate the limit of x squared plus 2x plus 4 at 2 by directly substituting that in, which will give me 2 squared plus 2 times 2 plus 4, which is 4 plus 4 plus 4, or 12. And remember, my final way of writing this would be f prime of 2 is equal to 12. All right, so in this example, we're going to look at how to calculate the derivative of a function using our limit definition, which I have written right here. The limit as h approaches 0 of f of x plus h minus f of x over h. And we are being asked to derive f of x, which means take the derivative, given the function f of x is equal to 2x squared minus 5x. So I'll start by writing out my limit statement. It's the limit as h approaches 0 of the original function, and everywhere there's an x, I'm going to put x plus h in its place. Then I subtract the original function as is, and I divide by h. Now, from here, I've got a lot of simplifying to do. All right, so let's talk about these steps. Right here, I would need to expand. So if I do that, my little problem right here, I'd have x plus h and x plus h, which would give me x squared. I'd have xh in two places, or 2xh, and then h squared. I also need to remember to distribute that 2 to all of those terms. So that would end up being 2x squared plus 4xh, since I had 2 of them and then I multiplied by 2, plus 2h squared. Then here I'm going to distribute the negative 5 to both, so that'll be negative 5x minus 5h. And then here I need to be careful to subtract both of these terms. So minus 2x squared, and then minus a negative 5x will be plus a positive 5x, all over h. Now this next part is the fun part. We are looking for anything that cancels out. So for example, I have a 2x squared and a negative 2x squared, so those will cancel. I have a negative 5x and a positive 5x, so those two will cancel. So then from there, I'm going to go ahead and factor out 1h from everything in the numerator, which will leave me 4x in this term, plus 2h, because if I take 1 away from h squared, I'm left with 1, minus 5 over h. And the point of this being, we get a big 1 right here with those h's, which cancel out. So our final step will be to substitute that h value of 0 in. So when I plug 0 in for h, that value will be gone. So my final answer is 4x minus 5. In other words, the derivative of my function is 4x minus 5. And last but not least, let me preview the power rule with you again. If you watched last week's review and preview, there was an intro there as well. I'm going to take it a step further today. Now, I'm not going to teach you what the actual power rule is, but I'm going to show you some examples and hope that you can have that big aha on your own. So you've been doing derivatives by definition, which is kind of a longer process. I'm telling you, once you know this power rule, you're going to be able to do derivatives as quickly as I am right here. So I know using the power rule that the derivative of x cubed plus 5x is 3x squared plus 5. I also know using the power rule that the derivative of 5x squared minus 10 is simply 10x. I know that the derivative of 7x to the 10th minus 3x to the 5th is 70x to the 9th minus 15x to the 4th. Now, this last one is a little tricky, and I wanted to introduce something to you first. Now, in order to do this as a power rule problem, I would need to rewrite it in power form. So that's why we were practicing this way back at the beginning. So I would start by rewriting that root in power form. The power is 5, the root is 2. It's always power over root. And then my last step would be to bring that up to the numerator and putting that negative exponent on it to denote the fact that I moved it. So once I have it in power form, it's pretty easy to take the derivative. So my derivative for 3x to the negative 5 halves would be negative 15 halves x to the negative 7 halves. Now I'm going to challenge you. If you were able to see the pattern on these three, see if you can figure out the pattern here. Because if you can get this one, boom, you're in a good place. All right, team, have a great rest of your weekend. I appreciate you watching, and we'll see you next week.